Hey everyone. Let's move to the slides. So, hello. How's everyone going? Hopefully your day is doing well. Hello. Uh, so a brief introduction to myself. Okay, a brief introduction to myself. I'm Muhammad Kamar. Just call me Kamar. I'm still keeping the brief intro from last time. I'm a senior software engineer at Agora. I like Python, the programming language. I like ThaiPy, this conference. And I like the pizza here. It's pretty nice. Everything here is nice. So with the intro out of the way, we can start with the talk. We're going to be talking about Python with gRPC. It was Python microservices with gRPC, but due to time limitation, we're not going to go into the microservices part. We're just going to go over Python with gRPC. We're going to do a live setup, and we'll see. First, let's go over the chapters. First, we're going to go give a quick introduction to Oh yeah, good point. Yes, yes. Okay, so we're gonna give an introduction to gRPC. We're gonna go over some basic concepts of the web, because I know not everyone here is a web developer and might not be familiar with web servers. We'll go over understanding gRPC protocol buffers. We're gonna do some live codings, set up Python environment to gRPC, build some protofiles, run some server with some requests and responses, and we're gonna check some success stories, some limitations, and finally, we're gonna do a conclusion. We can start with the introduction. So gRPC. gRPC is for those that attended the last talk, you guys know that I like to go over the official website and see how each technology defines itself. And so from the official gRPC website, they say, gRPC is a modern open source high performance remote procedure call framework that can run in any environment. That's like a huge definition with many, many words. Another definition from Wikipedia is gRPC is a cross-platform open source high performance remote procedure call framework. Okay, also too many words. We don't necessarily get a lot of them, but we can just take a few conclusions. And if we also just go over the main website, which is brief enough, explain some stuff. We think that it's just a framework for communication between servers, clients, etc. It goes over RPC methods, which we'll go over as well. It's pretty fast. They highlight that it's pretty fast and efficient many, many times. It requires protocol buffers. It runs over protobuf protocols. You compile some stuff. We'll go over it. And then it's competing with REST. It went over to like many protocols that went over REST just because REST is the most popular in the web. We also get over it and works over HTTP2, which works over TCP. So we'll go over these in details again, because I know not everyone here is into web. We have data scientists, we have machine learning engineers, nice stuff, but we'll just go to the basics. So TCP is just a way for computers to make connection with each other, for servers, applications, just to make connections with each other. It has this three-way handshake, SYN, ACK, and now the computers are connected to each other. They can send messages to each other securely. Nice stuff. It's like bidirectional. On top of TCP, HTTP was built. And so HTTP is just a request response model. This is HTTP 101, 1.1. I don't think the entire screen is being presented because there is a title for the slide, but it's not here. It's okay. Can we see it? Oh, nice. Yeah, thank you. Yeah, this is the easiest IT fix ever. Thank you. HTTP1 is just request response. They had to, like, for each request, you reinitialize your TCP connection, and then you destroy it. It wasn't efficient. They did an upgrade for HTTP2. It also wasn't, sorry, HTTP 1.1, which also had its issues, but mainly it was request response. Over HTTP, so we have TCP, we have HTTP over it. Over HTTP, we got RESTful API, REST. And so REST, again, it just goes over the request response, but it specifies a way to communicate between these, where on HTTP, we have HTTP request headers. We have the types of requests, which are like get, post, delete, and put. And it specifies how URL should be structured, where should you include your IDs, what your server should return. It has like these very extensive rules that the creator of REST created, and he keeps criticizing people on Twitter that don't follow that methodology. But it just specifies how we structure our request, and oftentimes the server will just return a JSON, and it's pretty great. It works on most cases. Every single web developer will create a CRUD app. It'll run over REST. It goes over JSON. It's cool. HTTP2, however, which we can run REST over HTTP2, but it was an upgrade. We had an upgrade for HTTP 101, and we can see a diagram where if you wanted to retrieve, if you wanted to fetch multiple files from HTTP 1.1 or 1, you had to like send multiple requests. HTTP 1.1 sort of fixed that with something called pipelining, but it was also wasn't great. So HTTP 2 specified that you can just, with one TCP connection, you could just retrieve many, many files. It's much more efficient. It's greater already. It's much faster. You don't have to send as many requests. Great stuff. And now we have gRPC, which runs over HTTP 2. So we know that it doesn't need to use these many requests. And it runs over this HTTP 2 protocol that has one request. So what really is gRPC? In summary, is just a standard for communication developed by Google. Now, it's developed by Google and another partner, which is not often mentioned, and I forgot to mention it as well, but you know. It's just a standard for communication, just as the other standards. And whenever I read the word standard, I remember this comic from XKDC, the mandatory comic, which says like situation, there's 14 competing standards. And the guy says like 14, ridiculous. We need develop our universal standard that covers every use case. And like the person agrees, yeah. And then soon you have situation, there's 15 competing standards afterwards. And so whenever someone wants to add a new competing standard, a universal standard, that doesn't work, and people just end up having more standards. But gRPC is different because we can see like why use it. So it has an interface definition language, which many other frameworks do. So an interface definition language is just a language that you specify in the middle that both components, both servers will be able to communicate through. So uses protocol buffers in this case by default, allowing for well-defined methods for service and data structures, okay, and data definitions. It goes over HTTP2, which we already discussed is pretty more efficient than HTTP1. It has streaming capabilities, and so you can, instead of just sending the request through your stuff as one bulk request or receiving the response, the communicating parties can stream data through, so it's even better in that case. We have language agnostic, so gRPC, again, developed by Google, has many, many resources, can create SDKs for every language, and so if you have a polyglot application, some part working with Java, some other part working with Python, it'll work with that. We have pluggable support. You can add some plugins. There's authentication, load balancing, retries, etc. It's nice stuff. It has a lot of nice features. And so it might be just a new competing standard, but it has a lot of stuff in favor of it. It also has this reflection API, which I added like right before this meeting, which is pretty nice. Like it's a very easy way if people have to work with the Swagger API, where you create like an open API doc and you get to see your endpoints and send requests. You can also create very, very easy UI to see your endpoints that you're exposing. So here, there's a greet request. You can send it. You can specify how you want to display it. It's very easy to just create this UI and see all the endpoints that your server exposes. Just work with it. It's nice. What's protocol buffers? We've mentioned multiple times that gRPC works with protocol buffers. So it's an extensible mechanism for serializing structured data, similar to XML, but smaller, faster, and simpler. And all of this means is it's just a way that you create a proto file with some definitions, and it allows a compiler to encode your data very efficiently using those definitions. And there's another decoder that can expand them again. You can understand them from a machine to another. And this encoding and decoding becomes very, very efficient. We have some private stuff. OK, yeah. So just protocol buffers, again, it's just the way that you define definitions, send over the wire, decode them again very efficiently. Much more efficient. So if you go over REST APIs that often work on JSON data, JSON is just string. Now everything is turned into bits and bytes, but protocol buffers allow you to compress them, to stream them. It allows you to do a lot more extra features over this data. And again, it minimizes it a lot. I think the microphone is, I have to remember to keep it close to my face, otherwise people won't hear. But if anyone is having issues hearing, do let me know. So let's continue. We have protocol buffers. We know that gRPC uses protocol buffers. Why use protocol buffers? Again, lots of advantages. It's efficient, typically requires fewer bytes. It has a simple interface. You can just define your definitions, compatibility. So if everything here is vague, we're going to go over like live coding example, which is very frowned upon in live talks. But we'll see how it goes. Like if everything here is very hypothetical, we'll just go over it live. But it has a similar interface we'll see right now. It's very compatible with like all of the, it has upgrading, downgrading elements, making suitable for involving in systems, and it has rich data structures. So enables embedding complex data structures and hierarchical data. Again, we'll take a look at all of that, I think, now. So we can set up a Python environment for gRPC. So to implement gRPC in a Python project, this is a Python project, a Python talk overall. We need like two main libraries, gRPC IO and gRPC IO tools. And so gRPC IO allows you to create a server. So you want to run a program, you want to create a server that has the ability to take gRPC connections. You use this library. And there's gRPC IO tools, which allows you to compile protocol buffer files that we're just talking about. You create a protocol buffer file with definitions, and you listen. If you want to create a server, you use this library. So we can do these live. I believe I have Visual Studio Code here open. We're gonna go with not live. We're gonna go with a simple example here. I can write. Actually, let's open this one. So we have. Yes. Yeah. Okay. So let's zoom in. Let's expand this, and this is the live version with no modifications. So this is how a proto file looks like. So at first, you specify you just say your syntax is proto 3. There's proto 2 and proto 3. Right now, the latest version is just version 3. Okay. I think that's good. Okay. We can probably zoom in actually even more, but there's some more files that are a bit bigger. But okay, we specify service was just, it's like a static class if you work with static classes that has some methods on it. We will use this service inside of our code. We'll generate some code, and we can call these methods. And we see that we're defining a method, an RPC in this case called say hello, that takes a hello request and returns a hello response. Fair enough. What's a hello request? Again, specified here. I'm using an extension, by the way, in Visual Studio Code for this highlighting. We have our hello request, which just says we have our requests will have a name, and these are tags that we use to just order the incoming requests, and the response will just have a message. And we have these definitions. We know that we have this method. We just define the stuff, how our request and response will look like. We can just run a command. Okay. I'll copy it from here. So first we can install the packages. I run pip3 because I have Mac, and I already installed these locally. So we can confirm that the packages are running. Let's just confirm that the package, is downloaded correctly, because you never know. Okay. Oh no, I ran the incorrect command. Wait, no, I didn't. Okay, I just ran a different command. Okay, spoilers, but we'll get to the spoilers right now. So let's write protocol buffer definitions. We already did this. We have our proto file. That's here. Our proto file, again, we just went over the basics. We ran the commands, and then we compile the command. We ran the compile command, which I just ran 2 minutes ago. So let's go over it again. We say Python 3, okay, we're running with Python 3. The module gRPC tools.protoc. We have the definitions here. It says I tells the compiler that the current directory is where to look for any dependencies in case your proto files have dependencies. Python out is just where you want to your output files from the proto definitions to come out. gRPC out specifies directory for generated Python gRPC specific code. Okay, this is for the classes. This is for the directory for the gRPC code. And once we do run this command, so let me just delete these again. Okay. And then we're gonna run our command again. So we're saying, hey, for the hello service, run this module with these parameters, and then we can run it, and it'll just automatically create 2 files for us. Now, if you're curious, you can view what these files have, And if you're interested in modifying them, like it says here, generated by the protobuffer compiler, do not edit. So do not edit these. I wanted to edit them, and then I read the message. And these are just the generated classes from that. This is just a Python file, and we can import it in our server. Now we can see here that when we want to create a server, we import gRPC, we import concurrent features just to create a server, and we import these files that we just created. So it creates two files. We have their definitions here. Service pb2.py. Again, we can specify these names, but one that contains message classes, just the classes. We can see it live. So this is that. It just has the classes. It has like descriptor, globals, build descriptors, blah, blah. And there's another file which contains server and client classes, which is a bit more complicated. Again, we don't need to go over these files. They're just auto-generated from your proto file, usually just created, and forget about these. But we can see all of this auto-generated code by Python that we can use. And so let's go to the next slide. We have the screenshots here of what we're going to do, where I did that, already did that, lots and lots of code. So we went over the simple service. Let's implement the server and client for Python and show how they're working together. So we'll have this file called server.py here, which is just a basic server. As mentioned, the package gRPC will help us create a server. In this case, we just say server is equal gRPC.server. We give it a thread pool of max workers 10. We don't care, we're just creating a server. And once we have that server, we say server.start. And we are listening at the port 50051, right? And now we have gRPC server, and that's it. It's pretty easy. And when we do want to add our proto definitions and proto buffer code, we say like add greeting service to server. If we like search for this, if we command shift F for this, we'll see it in the auto-generated code. We're just using this code here. And then this adds the methods to our server. And as we checked in our profile, there's a method called say hello. The same method, we're using it inside here. We define the method say hello. What do we want our server to do when it receives the say hello request? It just says hello and returns the name. So we can run the server, just Python 3 and then server. And now we have a server listening at port this. So just my laptop is now a server. Now I would do a live presentation and maybe host this somewhere, but I'm afraid of getting DDoSed. And I was just reading about a guy that got like a $1,000 bill from AWS. So let's not risk that. I'm just gonna make a quick demonstration of just running another a request locally from client.py. So client is very, very similar. We're using the same definitions. And so if you had like multiple code bases, you can have the same proto files, generate definitions for different programming languages. Great stuff. Client.py just creates a gRPC instance channel, connects to localhost this, and then sends a request. So in this case, we say hello request with the names equal to Alice. So this is the name of the request I want to send. Now let's just Python 3, Python. Yeah. So we're using the same, once we do have the definitions, we can use the same method. In this case, gRPC, we give the stub, we get the greeter stub, which is the definition file that we had before. We connect it to this channel, and then we say like response, say hello, we invoke the same method. So it's the client code and the server code from the stub, from the service that we created at the beginning. Now we say like Python 3, and then client. And what we expect is client, right? Python. I hear, okay, I thought that there's, let's see, client. For some reason, it's not completing, but. Oh, yeah. Oh, I'm in live, and this is also on live. Oh, it's in hello. Okay, so let's just cd into hello. Okay. Yeah, this is why. Okay, Python 3 client.py. Also no such file. Oh, client.py, okay. And then we run it, and we get, hey, greeter client received, hello, Alice. So we just send the request from our client to our server. We can also use a tool such as Postman. Hopefully, Postman is also zoomable. Yeah, we can use Postman. We say that, hey, we're connected to this. We greet your service. Postman gives you like some great tools. So it just says which method do you want. You can just autofill the method that automatically reads it. You import your, where is it? You import your profile, and again, Postman automatically understands your request shape and your response. And in this case, I'm sending a request to my server saying, hello, Kamar, this is my message, and invoke. And then if we go to our server code, terminals, we say, oh, we're not logging the output. I think I sent it to the wrong place. That's just the stuff. Hello, hello, hello. Response. Oh, yeah, sorry. We sent it here, and we'll get a response. Let's just expand this and check the response. Invoke. Not connected to Postman account. There's something that's not working. Sorry? Oh, where is it? Response, metadata, response. I can't see anything. Okay. I swear this worked before the presentation. Again, this is why you don't do live coding. But again, we have a server listening, gRPC server listening at this port. We sent a request to it through our client. We can send a request to it through Postman. Postman is pretty great with this. We can continue with the presentation. Let's see. Where are we at? So we implemented basic gRPC server. We did the server and client actions. This is the server code. Again, all the screenshots are attached. I'm gonna put them in my GitHub. I think I've got the link in my, but oh, okay. We have a sample Postman working actually. Let me just put it on slideshow again. And this is, so you send name Kamar and it returns message, hello Kamar. Oh, it's showing the message actually. Okay, so I'm just sending the server my message and it returns me back hello with my name. And this is an example of it working. Let's check some success stories. So the first success story we're gonna look at is a company called Vendasta Technologies. I like the official website. It says, turn your digital agency into scalable powerhouse. Okay, it develops some tools. They have a long blog article about what they did, their transition from REST to gRPC. So they do digital production platform. They needed to handle increased scale. They wanted to move from RESTful API using HTTP.json to gRPC with Go programming language. What they got was performance enhancements, drastic reduction in API response time. So this is one statistic that got me scratching my head. So they said that their API response time went from 1200 milliseconds to 4 milliseconds for medium responses. So this is like huge reduction in response time. And they have a lot of graphs showing, but this is on the gRPC official blog. Let's go to a gRPC blog. They mention what they did. It's somewhere in the blog. I linked it. Oh shit, stop. Okay, let's go here. Yeah, so they saw performance enhancements. They said that their developers are now more productive because they're dealing with SDKs. They're now more efficient. Enable streaming, they can enable streaming. All the benefits that we talked about. The other success story today is a company called Weaviate. And so Weaviate, the new AI native database, is just databases for new generation of software. Same thing, success story. They moved from REST GraphQL to gRPC. Same thing, they saw speed, they saw efficiencies, they saw scalability, maintenance, developer operation, and gains. And good stuff. On the gRPC website, at the bottom, they say that gRPC is used by Square, Netflix, Cockroach Labs, Cisco, and Juniper. Juniper, great stuff. Limitations and considerations. So, okay, gRPC is great, but should I just use it for everything? In this case, browser support. So if you go to the gRPC web, there's a GitHub repository just called gRPC web, which is gRPC on your browser. You can use it on your client, but it doesn't support all the features. So a variant of gRPC is needed for client-server communication, but it misses some features. Human readability. So when you're dealing with JSON, you just throw some JSON, get some JSON back, and everything is readable. You can debug it. You can run it over some proxy. You can see everything. While for gRPC over protocol buffer, everything is serialized. You can't really debug that great. Some firewalls won't allow you to send the request through HTTP2, which isn't great. And finally, compatibility, implementing, maintaining can be more complex than just REST. And again, for all web developers that just start, take rate, take RUD, a CRUD application is very easy, while in gRPC it might be more annoying. But I think that's it for the limitations. The conclusions, pretty simple stuff. What we know, let's just put it back in the slideshow mode. Okay, what we know so far is just, we know what gRPC is, hopefully. We know protocol buffers are, we know how to implement them with Python. What do we take away? gRPC is pretty cool, in my opinion. Again, I'm not sure about everyone else's opinion, but it looked pretty cool. It looks like it'll make things faster and more efficient. It may be hard to implement. Again, not everybody needs gRPC, and as mentioned at the beginning of the talk, it was titled gRPC and microservices. That's where it's being used, where companies have millions and millions of requests and care about every tiny efficiency. They will need gRPC. Maybe hard to implement, not always supported. And the final conclusion is just give it a go. There's a nice Python tutorial on their website, grpc.io/talks, and you can see the tutorial. And that's the end of the talk. Thank you. How does it work on what, sorry? On the browser. So the browser is able to send HTTP requests, and it's basically the same thing. You just define your protofile. There's a JavaScript library for it. You use npm, compile your protofile to some JavaScript files, and just send it as well. It's the same thing, just HTTP2, which is already supported. Again, there is an official GitHub repository for the documentation, but it's not much harder than implementing on the server. It's just that some of the features are not working yet. They do say that they're going to implement everything, but it's not all there yet. Yeah. That's it.
You mentioned a case where something was sped up 300 times, I believe.
Yes.
Do you think that was because of the time required to generate and parse the JSON, or the streaming, or other ideas?
So from their blog, they just say that it's just literally JSON being inefficient. So JSON is just all strings. For every single new line, you have to generate a new line character. If you ran like JSON.stringify on JavaScript before you send the request, your request is already seems pretty large, and then you run stringify on it. It adds many new line characters, many characters. Protocol buffers are really actually pretty small. I should have given an example, but like tiny. And from their perspective, again, you just deal with the overhead of like compressing the data at the beginning and sending them. This just makes it more efficient. It just seems that it is actually just that much more efficient than JSON is.
YAML is many times worse, by the way.
Yeah. Yes. So it's just sending binary data back and forth. Yeah.
Do you have any like performance comparison with like gRPC and GraphQL and tRPC?
There are stories online. I'm pretty sure, like, if you just Google these are just the top 2 results that I got when I searched online, like migrating to gRPC. You get many articles. There are stories of that, yeah. Actually, for this one, I think for Wave, these guys were using, REST plus GraphQL, and they moved. But they don't, actually, these guys do have many graphs on their blog. Not here. Yeah, here. They give a lot of statistics of how their application performed. Many graphs. It's nice stuff. You can check it out. I should link it in the ending slide, and maybe we can put this online, this presentation. Yeah.
So two small questions. The first one is, HTTP2, if I understand correctly, runs over SSL, right? In your sample code, I don't see any certificate set up.
Yes.
Yeah.
We just have this here called add insecure port. So you just explicitly say to your server, hey,
yeah, the port is insecure, but you still need a certificate, right? How did that happen?
No. So okay. So when I specify where I want to send the request to in my client.py, I just say like, actually gRPC even handles it. But yeah. But you can still send it on over HTTP normally. So when you create an insecure server, you don't need certificates incoming to handle your requests.
Okay. So the second question is, like when we have with REST, right? We have very popular frameworks like Flask, Fast API. So what framework is there for gRPC, and is that like considered production grade for Python?
Yes and no. So oftentimes I think just the gRPC library itself is going to be enough. But if you search again for like Flask gRPC, you will find some SDKs from Flask to gRPC. They are used in production. I do have to add them, but if you Google for the like Flask gRPC, you will find an SDK. If you Google Django gRPC, you will find like a middleware that uses gRPC. You can set up your server to also multiple ports.
Yeah, I have a question about web development. So if you write an endpoint and want to return some gRPC code instead of JSON, and I don't want to rewrite my whole code base, so I just put a wrapper around an endpoint, and it will parse like a pydentic to a gRPC, so we can easily transition our usual REST backend to gRPC quickly, or not.
Yeah, I don't think so. So although the Postman example that didn't work does return the stuff as JSON. Oh, response, there we go. But not here. Anyway, although the example does return it as JSON, but I don't think you can just create a wrapper, because from all these articles that I read, they do go over every single endpoint and just transform it into a JSON, gRPC. Now, there are other articles that I read that would do a zip of your JSON data before you send them over over the wire. So it's sort of similar to just binary data that Beta was talking about. But again, it's quite different, just normal JSON, than the serialized data that gRPC sends. So it's quite different. Okay.
Okay, couple more questions if there are any. Yes, one from Dylan. We'll go over the back there.
So one of the reasons they say GraphQL is more efficient is because it kind of leads you to creating an API where you can just specify exactly the bits you want and not bring all the data down. Does gRPC help with that, or is it more like REST that it's up to you to design the API?
Yeah, so gRPC, I read that a lot, that gRPC allows you to specify exactly what you want. It prevents the overfetching of data that, again, REST has, underfetching of data where you have to fetch multiple requests. gRPC, just given that it's an RPC, it isn't necessarily bound by these, let's see, where is it? Like get, post, let's see. So with the HP, you have like get, post, delete, input. gRPC allows you to create different types of API, like a calculator API, which is another example that I wanted to show, but things didn't go as smoothly. But these different types of APIs can be more efficient. Maybe it will be inconvenient to implement everything in GraphQL in the first place. I imagine GraphQL is more similar to REST than gRPC is to both. Again, just because it's remote procedure call, and suppose you're just invoking a method on the other server, as opposed to just having these methods. Yeah. It's
GraphQL would be more different, I'd say.
yeah, it's very, very different. Again, this is like in terms, REST is a remote procedure call like nRPC, but again, the procedure calls that you're doing are just these methods, get, post. While if you're running gRPC, you're allowed to add a lot more methods in this case.
Yeah, one from the back here.
You have to.
Yeah, so I just was wondering if you have, so when you compile like the gRPC Python code, what happens if you use a client and a server that don't match? Like they were compiled from different messages and you put them together. Does it like throw an error or tell you that?
Many errors. I'll give you. So the error types actually were a big complaint point from what I read. Like the error types were really undecipherable in that case. But apparently they're working on it, but it does throw just many errors.
Like versioning would be a.
Yes. That's why, like at the beginning of every gRPC, at the beginning of every proto file, I have like syntax proto 3. I imagine this will remove the version conflicts that will happen. Just proto 4 and done.
Thank you.
Okay, one more. Sorry, one more last question, and then Kamal will be here over drinks to answer other questions.
So I think we already had this conversation outside. So I do understand that gRPC would be great for data pipelines when you're sending huge amount of data from one service to other. So on the questions you got previously, don't you think that most of our web development has little JSON data over the internet, right? So don't you feel that gRPC is a bit overkill for web development? Because given the complexities, obvious complexities we have to deal with gRPC.
Yes and no. So it depends, right? It depends on how big your project is and how much data you're dealing with. So if you have enough developers, then the complexity of implementing it maybe just like you wouldn't use a third-party service, you'd build it in-home. If you have enough developers, you can make anything possible. And the way you justify it is that, again, if you have billions and billions of data, such as Agoda has, these efficiencies in the data pipelines will just make it a lot better, a lot faster. You would save up a lot on server time, on parsing of the JSON data. You just zip it and send it. Much, much, much more efficient. So it justifies itself in bigger projects, maybe not much in smaller projects, yes.
So do you think that it still holds good for web development?
It's still what?
Still useful for web development at scale?
Yeah.
gRPC?
I mean, yeah, again, in any inter-microservice communication with company with enough customers or enough data, yes, it definitely is.
How about sending it to the front end?
How about?
Sending the data to the front end client.
To the front end, I don't know, honestly. I haven't, like, again, because I didn't go over the part of the front end much, but good question, yes.
Yeah, it sounds like a good conversation for a beer or a drink in your hand. Super last comment here.
I think that's the one. There's one tagline he hasn't mentioned yet in the talk because I think it's like an introduction, right? But there is also like there's also like a stream event on gRPC as well. So I think like that might actually be something that is like very unique because like it doesn't GraphQL does not offer stream. Then I'll take a look at it one more time. But I think like in terms of like large amount of data over web, like the gRPC stream performance is actually really, really good.
Yeah. I think there's some very interesting discussion developing here. Perfect time to have a break so you guys can have that discussion. Let's have a break for 10 minutes. Thank you, Kumar,
Right.
for
Thanks,
the
everyone.
talk. Very interesting. We'll be back with John in 10 minutes. I think there's still some drinks out there, so please stand up, continue that discussion, and we'll be back in 10 minutes. Thanks, everyone.